WASA Distance Education. This is MBF3C, Grade 11 College Prep Math. I'm Pete, and I'm your teacher. So welcome to our first class of week 3 of the course. So yesterday was a holiday, family day, so you didn't miss anything. Now we're starting Unit 2 today, so that's in Lesson 6. So you'll need your Unit 2 handout. Now hopefully you have that. If not, we'll just you can just follow along here, and you'll be able to get it. Now it's gonna be a bit of a change of pace here for us because we've been doing algebra up till now and looking at polynomials, looking at parabolas, and different types of ways to manipulate them. Okay, so we're going to change a little bit, and we're going to actually look at money. So that's a kind of a fun topic, I think. So most of Unit 2 has to do with investing and calculating interest and things like that. So and it's really very practical material. So so let's take a look at what we got. Okay. Now, besides working, another way to get money is through investing. Okay, and the easiest investments are savings accounts. If you have a bank, you have a little bit of money, and basically you're going to lend your money to the bank, and then they pay you to do that. Okay, and this payment is called interest. So, and they're basically renting your money from you. That's what the banks do. And if you have money set aside that you're not going to need for a while, 3 months or more, it really should be invested in order to make the most of it, right? It doesn't have to be a lot of money either. Especially with a savings account, it can be a relatively small amount. And then the bigger investments, you need a few $100s, like term deposits and certificates of deposit and things like that. Okay, but you can start small. Now, presently, the interest rates that you get on savings are pretty low, and that's just because of the whole economy thing. But they become low for a while, and then they go up, and over time, interest rates will eventually go back up. Now, of course, the other way that this happens is when the bank lends you money, such as when you want to buy a truck, right? You want to use your credit card or something. They charge you interest. Okay, and so that term interest just means money earned or paid for the use of the money. It's rent on money. We just call it interest instead of rent. Okay. Now this simple interest, which is not really the way that banks calculate interest, but it's a good way to get started in looking at interest. Simple interest is given by a formula. And they don't remember, this is an algebraic formula, so it's I equals PRT, which actually means P times R times T. Okay, so we just write the letters together, I equals PRT. Okay, and what it's telling us is that the interest earned in dollars, and it's a capital I, is equal to the principal. That's the amount of money that you start with. So let's say that you have $100 to invest. Somehow, you got $100. You were, you won the fishing derby, or you got, well, I guess normally you get a truck for that. You got a prize in the fishing derby. You got $100, so now you're going to invest it. So that would be your principal. Okay, principal. And R is the interest rate. Normally in years, which could be a fraction. If it's half a year, it's going to be the interest rate is just expressed as a decimal. The time in years could be the fraction if it's less than a year. Okay, so actually that's kind of a bit of a mistake where it says interest rate. By the way, we're on page 2 of our Unit 2. So if you just joined us here. Okay. So I guess the best way to look at this would be to take some examples, right? The interest rate, normally we talk about, say, 5% interest, right? But that 5% is percent per 100. So what we need to do is divide it by 100 in order to turn it into a decimal. And this is the number that we're going to use when we do all of our interest rate calculations. Okay, and that's the interest rate per year. Now, the little box here, it says we don't always put it in our money in the bank in even increments of 1 year, and that's why the time can be sometimes expressed as a fraction. Okay, so if time is in years and it's 1 year, it's going to be 1. If it's 2 years, it's going to be 2. But showing in this example here, if it's 16 months, then we're just going to express it as a fraction. There are 12 months in a year, and it's 16 months out of 12, and that gives us what, 1.2, something like that. 1.5, sorry, something like that. Right? Actually, I don't know if okay, 1.3. Yeah, I knew there was something wonky there. Anyway, we don't. When you're plugging these into the calculations, you could just leave them as a fraction. You don't have to reduce them or anything. And the reason is that that makes sense to someone that's looking at the formula. We know what you've done there, right? We know that the time is 16 months and that you've turned it into a fraction. So let's say that was 48 weeks. Right, so 48 is not an entire year because there's 52 weeks in a year. So what we do is we express it as a fraction over the number of weeks in a year, right? So 52 over 52 would be 1 year, but in this case it's 48. Okay, I'm going to redo that because oops, I changed colors too. So it's going to be 52, and the fraction is 48 weeks out of 52. Okay, and that's how we convert a less than a year into a year, and it works. The one above was more than a year. Okay, and for days, for the purposes of this course, we're just going to assume that a year is 365 days. Okay, now I know that's not entirely accurate. Sometimes it's not, but 365 is a good, reasonable approximation to the number of days in the year. So if somebody says, all right, 600 days, then it's just a fraction, 600 over 365. And I guess I'm just going to rewrite that in a different color because, all right, so it's 365 is the denominator. That's the number of units in the year. So in this case, it's days. And 600 is the one that we actually are using. Okay. So let's take a look at an example using the simple interest formula. So Sam invested $800 for 2 years. Okay, they paid 5.5% per year. How much interest was earned? Okay, so the formula we're using, I equals P times R, that's little r, times T, that's little t. And what we have to do is, to be able to solve this, is have all three of those values. If we don't have those, but we have the interest, then we could solve the one that's missing using our algebra skills. So the best way to solve these, I think, is just to write things down as you either see them in the question or work them out. So the $800, this is our P. That's our principal. That's how much we start with. That's the initial investment. Okay. So, who knows how how Sam, he or she, got the $800. Maybe he saved it. Maybe he had some, summer job, whatever. Maybe, maybe he just had a little extra income, had a particularly good year. But he got $800, and so he doesn't need it for 2 years. Maybe he's saving up to buy a truck, right? Maybe he's saving up to take a vacation. Maybe he's saving up to go to school. So he's going to put that money in an investment for 2 years. So our interest rate is 5.5%, but we can't use it that way. We have to turn it into a decimal by dividing it by 100. Now, pretty soon you're gonna get to see this and be able to do it without too much trouble. I really didn't write that so well. Let me try that again. Okay, so it's 0.055. Now, notice this 0 here. Sometimes when we're doing it on a calculator, because it says 0.0, it's very easy to miss that beginning zero. So a little trick is that if the interest rate is anything less than 10%, you're going to have that leading zero. So anything under 10%, you're going to have that. It's going to be 0.0 something. Okay. Okay, so that's the interest rate, and then our t is just the time, and it's just 2 years. Okay. So the way we work this out then is just I, the interest rate in dollars, is equal to P, which is 800 times our R. Now be careful here because you have to use the decimal version of it. And T is 2 years. Now, let's say that we made a mistake and we used a non-decimal version, and let's say we used 5.5. What would happen is we'd get a very big number for interest rate. Okay, and that's part of the 4-step problem-solving model that we use. Part 4 is to look back and ask yourself, does this make sense? Did I do it right? So if you're getting interest rates in the millions of dollars, chances are that it's probably a mistake in there somewhere. So we just multiply these three numbers together. So I just do 800 times 0.055 times 2, and I get $88. We didn't even have to round anything off. So there you go, $88 for the year, for the 2 years. So what this means is that Sam, at the end of the 2 years, they're going to give him back his $800, and they're going to give him another $88 that he didn't have before. Okay, so that's not a bad deal, which means that Sam has that money to invest again. Let's say Sam decided that he didn't need it right away. Right? He could take that $888 and reinvest that and get some more interest. So that's sort of the way investing works. Okay, and you can start small. Whoa, what did I just do here? Okay, let's back up a little bit. 88. Okay, I was just talking about things not making sense. 0.55 times 2. 800 times 0.55. Okay, 5.5 divided by 100. 0.55 times 2, yeah, times 800. Okay, I got $88. All right, let's go see what they did on the next page here. 22. Don't know. 800 times 0.55. Oops, 0.055 times 2. I don't know. That doesn't seem correct. Anyway, if you find my mistake, then let me know. All right. Okay, and should be 88, I think. Okay. Okay, so and it shows you sometimes there are mistakes here. I don't know. We'll see how I do with the next one. See if I got this. So example 2, a savings account. So that's pretty typical. If for small investments, for anything less than a couple $100, usually it's going to be or a casual kind of saving where you're not saving up, thousands of dollars. Usually it's a savings account. Okay, so a savings account pays interest at 3.75% per year. So that's 3.25%. Now to use this for R, we have to first convert it into a decimal percent. A 3.25% is just 3.25%. 1 divided by 4 is 0.25. Okay. And then we're going to convert it to a decimal. Okay, so there you go. That's the decimal version of our R. Okay, so that was our R right there per year. The account has a balance of this amount of money. So there's our P, 248,761. Our R is 0.0325, and now all we need to solve this is our T. No deposits or withdrawals happen during the month. What is the interest that is deposited into the account on January 31st? So our T is 1 month out of the year. So be careful with questions like this because they've given us an annual interest rate, but we're being given a T which is only 1 month. Okay, so remember how we do that. There are 12 months in a year, and we're only going to use one of them. So T is 1/12. Okay. Oh, okay. It's interesting. They did 31 out of 365. Now that's an interesting approach. Probably works. 31 days. I wonder how much difference it'll be. Okay. All right. Well, let's try it. So I'm running I equals P times R times T, which is 248761 times. Okay, I'm completely out of room here. Okay. So I'm just going to have to give myself a new page here. So you can still follow along on page 3 of Unit 2. Okay, so page 3 of Unit 2. Okay, so what we got here, I got P is 248761. R is it's 3 3 and 3 3/4. I kind of percent. Okay, I think I might have botched that actually. 0.0375. I think I put quarter. I'm just gonna back up here. Yeah, I misread it. Wow. Okay, so that's 3/4, and that's going to be 75, and that's 0.0375. So I'm just fixing it just in case someone's looking at it later on. By the way, that's the way you fix stuff in math. I mean, you don't have to rewrite anything as long as it's understandable to, your teacher, to other math students, then it's perfectly fine. Okay, so I know that some teachers like to make students rewrite things. I'm not one of them, and I actually discourage it because it wastes time. Right? Math is a rough draft. We fix mistakes as we find them, and we don't redo things just because of a small mistake. Okay, and now I said that the T was 1 month. Okay, and the question is that a correct approach? Right? Because that would be 1/12. What they said in the solution here is that the T is 31 days. Let's have a look at what it says here. It says the account is a balance on January 1st. No deposit or withdrawals happen during the month. What is the interest is depositing the account on January 31st? You know what? They're absolutely right. It is 31 days. Okay. They're using 31 days. It may not make much difference, but let's do it. And that's 31 days out of 365. Okay. So, because really it's the interest is accumulating for a period of days, not a month, right? That's not a very accurate a way to do it. So, let's go. I equals P times R times T. I usually start with the formula. And so our P is 248761. Now, what are we expecting out of this? It's only a month, 3.75% interest. Maybe what are we expecting? About $20, $30, something like that. Not a lot of money. Okay, a very, very small amount. Now let's use the right 375. That's the right interest rate, not the percent, but the decimal version of it, and then 31 days out of 365. Now, in case you're wondering how we know that it's just 31 days, it's the month of January. So you can look on a calendar, look on your iPhone or whatever, and you'll see that that particular month has 31 days. Okay, well, I cranked this into my calculator now. So 248761, just have to make sure I get all the numbers typed in. 0.0375 times. Now, the way I do this is I can actually just do 31, okay, and then divided by 365. Okay, I don't really have to do anything special for that. So it's 7.92, and that's in dollars. Okay, so the interest was okay. Now that doesn't seem like a whole lot of money to make, but you're not gonna use it. Like, you're not gonna take money that you need, or money that you were going to do something else with it, and just put it in the bank to make interest. That's not the way to do it. The way you do it is any money you're not using right away, you can put it in that bank and make interest. Okay, if you use the money right away, no, you really want to, you don't want to just kind of do without or something like that. Now, the other thing is that if you know you're not going to need it for a year or so, there are better investments. But you got to be really sure, because the better investments, they usually lock you in for 6 months or a year or so, but then you make a lot more interest. So it was $7.92. So my estimate, I think I said $20 or $30. So it wasn't too bad. The point is that if we got 10 million for our answer, if we got 7,000, if we got anything that was even close to the principal, you know that something's up, right? Because you're not going to double your money in 30 days. You're not even going to, at these interest rates, you won't even double it in 10 years. Okay, so something to keep in mind. All right, well, let's go back here. So indeed, they got the $7.92. And now we got a example 3. And this is a case where they're telling us what the I is. So the 4-step problem solving model is to, first step is to understand the problem. And the way I like to try and understand a problem is by underlining some of the key ideas in a question. So that's our I. So already we know that we're going to be solving for I. Paula received $1.25 interest on her savings account in February. Okay, she did not withdraw or deposit any money that month. Her interest rate is 4%. That's our R. How much was in her account to begin with? So what are they asking us? Okay, how much was there to begin with? Right? Well, how about P? Okay, that's the principal. Okay. So, they're saying account in February. So again, are we talking about the 28 or 29 days, or are we talking about 1 month's worth of interest? Right now, I see the question, they use it, they use 1 month as, right? So because we don't know which February it is, it could be a leap year or not, I think it's safer to go with 1 month. So P, we don't know the P. Right, we do know the I though. It's $1.25, $1.25. PR, our R is 4%. 4%, which is 0.04. We just divide it by 100 to turn it into a decimal. Okay, and then our T, 1 month. Okay, if you try 28 out of 365, that's probably going to be close, and probably be just as accurate. Or 29 if you think it might be a leap year. Okay, so now what do we got here? So I equals P times R times T. Now let's take a look at this, because we have the I, we got to solve for P. So let's just divide both sides by RT. So I have I over RT equals P. Now remember that whatever you do to an expression like this, if you do the same thing to both sides, perfectly fine. Equal sign means that both of the equal sign means both sides are the same. So if you prefer to write it P equals I over RT, that's perfectly fine. And that's the worst I think I've ever written. Sorry. let's try that again. I'm having a little trouble today writing on this board. I don't know what I'm... Okay, so P equals I times R, I divided by RT. If you wanted to flip everything around the equal sign, you're perfectly welcome to do that. I don't bother, just because it takes extra time, and I do solve a lot of these problems. But if you feel that you want the unknown on the left, you're welcome to do that. So now I'm going to plug in all the stuff that I know. So the I is $1.25. Okay, and the R is 0.04, and the T is 1/12. Okay, so there you go. Okay, it's pretty hard to see that 1/12. I'll write that a little better. 1/12. There you go. So the way I would actually solve this is just I do the denominator first, just because that 1 divided by 12. So 1 divided by 12 equals times 0.04, and I got a fairly small number. And now what I'm going to actually do is maybe seems a little backwards. I'm going to divide that, the denominator, by $1.25, 1.25. And now I have a number. Oops. Let's try it again. 1 divided by 12 times 0.04. Okay, and then divide by 1.25. So now I have a number, but I have to take the reciprocal of it. Whoop. Okay, don't. Okay, I just pressed the wrong. There we go. And so then, which equals, I don't know what that was, 325. Okay, so 375. $375. I'm doing well today. Okay. So 375. Now, when you're answering something like this, don't forget to put the dollar sign there, the units, because whenever we're calculating something, usually there's some unit. In this case, is dollar sign. The answer 375, while it's accurate, it's not entirely correct because you're missing the dollar sign. So, in case I was sort of talking through the way I did this. I actually I did the denominator first, divided by 1.25, and then found the reciprocal, which is the flipped over value of it, which mathematically is the same. It just allows me to do the denominator first, okay, and then I have a reciprocal button on my calculator, so not a whole bunch of extra steps. Otherwise, I got to divide 1.25, and then I got to wonder if dividing by 0.04 and then dividing by 12, how's my calculator gonna react to that? So for me, it's just better to do the denominator first. So that's how you solve a problem like that, where there's a different unknown than the I. You just manipulate the formula, and I hope you'll agree that these ones are a lot easier to manipulate than the ones we've been dealing with in the last chapter. Okay. So simple interest. Let's take a look at, I guess we have another example here. Let's take a look at that. This is on page 4. Whoop, page 4. There it is. Okay. So Dan invested $1,500 for 18 months. So already there's our P, there's our T, right? And there's our I. Ah, there you go. What was the annual interest rate? Okay. So now we're gonna work that out. I'm just gonna start a new page here. You can follow along. We're on page 4 of the manual. Okay. So in this case, my P is $1,500. Okay. And my I, they give us my I is 1, 2, 3, 75. That's a lot of interest. So we're probably expecting a fairly high interest rate then, though it is a lot of money. Okay, and then 18 months. So T is going to be 18 months. Well, we're given the annual interest rate, which means there's 12 months in a year. So 18 out of 12. Right? It's going to be more than a year. 1.5, I think. Okay, I think we have everything. I, P, R. So we don't know the R. That's our unknown. Okay, so let's write it out. So I equals P, R, T. So what we have to do is divide the I by the P. Okay, let's try that again. Getting a little. I'm just looking at the tip of this pen here. Okay. So I, and then we're going to divide by the P and the T, and that gives us the R. Okay. I think that's correct right there. Okay. Yep. So we have everything on the left-hand side, and that should give us the right-hand side. I'm just going to go up to the top here. So the I is 1, 2, 3, 75 divided by the P. which is 1500, and the t, which is a fraction, it's 18 over 12, and that's going to give us our r. Keep in mind that what we're going to get for our r is the decimal version. We want to convert it into a percent. We'll have to multiply it by 100, not divide it. Okay, now I just crank that into my calculator, and however you want to do it. Let's see, 1, 2, 3. Let's see how this works out. 15 times 18 divided by 12. Okay. And okay, yeah, so I'm going to do the, I'm going to do 18 divided by 12, okay, times 1500. Okay, so now I have a number, 2250, and it's up to me how I want to do this, but basically I'm going to divide 1, 2, 3, 75, and then find the reciprocal. And so I get a value for r of 0.055. Well, to turn it into a percentage, we have to multiply it by 100. Multiply it by 100, which gives me, to multiply by 100, just on paper, you just move the decimal place to the right 2 times. Okay. And was 55.5%. There we go. 5.5%. So that's how you solve one where they don't give you one of the variables, and you just rearrange the formula to have the one that you want on either side, either left or the right. By itself is what you're trying to do. Isolate the variable. Okay. So now if you had any questions about this, you're always welcome to contact me. And see here. Okay. So yeah, so you can always contact me at the office here on Facebook, PW space Wassa. That's my work Facebook page, and you don't have to worry about me spamming you or anything like that. I just use it for work, and so I might occasionally put announcements up there or something about math, but that's it. Okay, so no pictures of dogs or cats with hats on or anything like that. I leave that to everyone else. Okay, or you'd have to check my personal one. Now, the next thing that we're going to look at here is something kind of related. If you think about the I equals PRT formula, if you look at a graph, kind of say I and T, something like that, for a particular interest rate, it's going to be some kind of linear, some kind of line. Okay, going to be something like that. Okay, so this is a linear type formula. Okay. Okay. Oops. Let's see here. So we'll go to the bottom of page 4 here. So we're going to talk now about linear growth. Okay. Now, and that's what simple interest is, right? Linear growth represented by a linear, that is a line on a graph. Okay, it has the word line in it. In a straight line graph. Oh, look at that. Okay. So arithmetic sequences in simple interest, okay, the growth is constant because the common difference is the same for each interval, and we'll actually talk about that. This is actually, if you have a table of values, the common difference or the first difference is the way to tell whether it's linear or nonlinear. Okay, so let's take an example. I think will make this clear. So it says here, Christopher needed some equipment for his landscaping business. He borrowed $1,000 from a bank. Simple interest is charged on the loan, at 9%. Christopher plans to pay off the loan in a lump sum at the end of 1 year. Okay. So create a table of values to show the amount owed after each month for the first 4 months. Write the sequence of the amount owed at the end of each month. Describe the sequence. Okay, I think we're... And then graph the relationship, describing the relationship. Okay, well, what we're going to see here, we're going to go through and use the simple interest formula. Okay. So the principal was 1,000, our interest rate in decimal form, 9%, 0.09. Remember I said that any interest rate less than 10 is going to have that leading 0 on it. Okay, and then our T is going to be, always going to be either 1/12, right, for the first year, sorry, for the first month. Okay, and then we'll just increase the T to 2 over 12, 3 over 12, 4 over 12 for each month. Okay, or the way you can do it is say, all right, well, it's 750 each month. Okay, and that 750 is added to the total each month. Okay. Now I see here that they've introduced the A equals P plus I formula. That is the amount of an investment is equal to the principal plus the interest, and that's actually always true. Okay, we've been doing that all along. It's just we haven't really mentioned it, right? If you have an investment, say $800, and you get $88 in interest, then your amount, the amount they give you back, is your original investment, $800, plus your interest, $88, $888. That's your A. That's your amount. Okay. So the way they worked this out then is they said, all right, after the first month it's 750, then it's 2 times 750, 3 times 750, 4 times 750. Okay. Now the important thing to notice here is that the difference between these two numbers is 750, and the difference between the second set of numbers is 750, and the difference between the third set of numbers is 750. Okay, now they call it the common difference, I call it the first difference, and the point is that for each entry in your table, okay, your Y value is going to go up or down by the same amount, a constant amount. That's how you know that it's linear growth. And unfortunately, this graph this graph is not really helping us much, because actually it'll help us because it shows us what a bad graph looks like. You see the two lines I drew there? That should be the 0 and the top of the graph, so that the slope of the line will be a lot clearer. Okay, so they've squeezed this graph down into a fairly small space. Okay, if you're going to draw a graph like this, it should go sloping up like that. Okay, this would be 4 months, right? This would be 0, and this would be $30 right here, $30. Okay, so it would go up pretty quickly. Okay, I think it would actually go up like that. Okay. Okay, so yeah. So it says here the relationship between time and months and the amount owed is linear because the rate of change is constant. What they're talking about, the rate of change, is this part right here, right? That is, as long as the gap between the x values is the same, and it should be, right? It should be, it's either every month or every 2 months. It's however often we calculate the interest. It could be years. That's always the same length of time. And then the y value, the difference between the consecutive y values, goes up by a constant amount. In this case, it's the amount of interest that's added each month, $7.50, 7.5, however you want to look at it. Okay, that's a linear relationship. Okay. Okay. And of course, we are going to look at nonlinear relationships, and usually the way to see those is that there's an exponent somewhere in the equation. That's usually the tip off. But if you calculate the first differences of the y values, you'll actually see that nonlinear growth, the differences are not the same. All right, so here's, I guess they just want us to do some practice here, working on uh, finding unknowns here, right? So the remember, this is simple interest, so I equals PRT, okay? And you can fill in the chart, um, by sort of rearranging the formula. Okay, so let's try D1D. I'm gonna make myself a new page here. This is a support question. So I'll talk a little bit about marking. I've been marking quite a bit. I think I've got one student's work that'll probably be done today to be marked, and then everyone will have their marks back. If I can reach you on Facebook, I'll send you a scan of your marked assignment just so you get it that much sooner. And keep in mind when you get your results back, I usually put some notes, especially if you've had some problems, because we're not in the classroom, right? So I'll show you how to solve the problem. Maybe refer you back to the text or something. And then if you're still okay with your mark, because sometimes you can have a problem with a question and it doesn't really do much for your mark. But if you're really unhappy with your mark in an assignment, just redo any questions you had problems with, or one question where you really had some problems. Just send it back in with your next assignment. You can just, as long as you make it clear what it is, right? Then just I'll mark it and I'll change your mark. Okay, it's that simple. If you get a bad mark on if you get a low mark on a question, or even on a whole assignment, just do the ones you want to get the marks to improve your mark, and I'll remark it and give you the new mark. Okay, so that's the way it works. It's a sort of a philosophy of teaching which says that your marks are based on whether you learned it or not, and how well you learned it. And so if it takes you a second try to learn it, you still learned it, right? So let's see, we're page 6, and it's support question 1 here. So what we're being asked to do is, I guess I didn't need the one. I'm having a little trouble erasing the board here. Okay, fine. Let's see. So we were going to do D, and it's just a table. It gives us the principal, 925. Now, you're not really going to have enough room in there to put your work, so, as long as you're confident that you got it right, you just stick the answer in there. And then our R is 0.04. Now, notice I didn't even put down 4%. Okay, our T, that's the one we don't know. And then our I, oops, I usually put the I up at the top here. Okay, well that's, and let's see. Yeah, okay, so, and then we have everything. No, we need the I. Okay, which is, the I is 1825. Okay, so this is just really to check to make sure that you're able to manipulate the formulas. So it starts with I equals P times R times T. We don't have our T, so we're just going to say I divided by PR equals T. Okay. Let's see, 18, 20. Okay, I don't know. Okay, so I'm just going to go up a little bit just so we're not using up so much board space here. So let's try this again here. All right. So our I is 1825, and that's divided by P, which is $925, times TR, which is 0.04, and that is going to be our T. Now our T will be in years. It's always going to be in years. So let's see what we're going to get here. So 925 times 0.04, and then okay, so equals 0.4932. So that's not quite half a year. Could that be 6 months? Could it be, right? But that's how many years it is. Now, let's say you do a question like that and you're not really sure. You can just flip to the, if we just go to the end here of the unit, we're going to have the answers for all the support questions. So I just have to find where they start. And no, that's not it. And then they have all the answers to the, there it is. Okay, so lesson 6, support question 1D. Okay, so there we go. So they gave us the answer. They showed the setup, which is exactly what we had, and they said approximately 5 months. So yeah, that's good. It's 0.49, right? So I'd take a fraction, right? 0.49 years. Okay, so you should find all of the answers to the support questions in here. Now, if you get one that doesn't match what you got, check it over, and don't go in with the idea. I mean, chances are that they have the right answer, but don't, if you can't find a mistake, then it's quite possible you found a mistake in a book, right? As you see, these books do have problems. So, and that's true of any math textbook you're going to find. Okay. All right. So that was the support question 1. Support question 2. Troy had an outstanding balance of, and it gives us the outstanding balance here. Okay, an outstanding balance. Okay. Ooh. Okay. Now we didn't really talk about credit cards, but that's really, in this case, you're not investing money from at the bank. The bank is lending you money in the form of a credit card. Okay. So the principal is the outstanding balance. Okay, 80 days is going to be our time. And then our annual interest rate, 18.2. Notice how much different it is compared to the savings. We're talking about 3 and 4 and 5% savings, and then the interest rate 18.2%. Okay, there's a huge difference between the rates the bank charges you and the rates that you can get. How much interest did Troy pay? Okay, so this is our rate, and what they want is the I. So I think we have everything we need to solve that problem. Okay. So let's try that. I mean, So this is a support question 2, and that's on page 6 of unit 2. Okay. So the principal we decided then was 1, 2, 3, 6, 90, and that says outstanding balance. So that's what he owes on his credit card for the month, right? Oh, he actually had it on there for P equals, okay, so I, we don't know the I. Oh, I think they want the I. Yep. They want the I, P, R, and T. So the rate is 18.2%, 18.2%. Divide that by 100 and 0.182. Now notice, because we got an interest rate greater than 10, notice that there is no leading zero there. So again, watch that. And then our T is 90 days. Well, 90 days, 80 days. Okay, let's try that. So it's 80 days out of 365 days in a year. Okay, so since it's given rate explicitly in days, it's pretty clear. All right, well, you know what? I think this is a pretty straight up I equals PRT type question. Let's try it. Let's I equals 1, 2, 3, 6, 90. R 0.182. That was probably the tricky part there, getting that into decimal form, and then 80 divided by 365. Now, you can multiply all these together. You multiply all the numerators, that number and that number, and then divide by 365. Okay, and that works perfectly fine. So 1, 2, 3, 6, 90 times 0.182 times 80 equals, and then divided by 365. Okay. And so I get 49. This is going to be dollars. 49, I got to round it off. 34, $49.34. So that doesn't seem so bad. Now I'm looking at that, and it makes sense to me. It seems to be about right. I'd be worried if I got like $400 or $4,000. That would seem to be excessive even for a credit card interest. Okay, so that's how much good old Troy pays to rent the money on his credit card for 80 days. Okay, now it doesn't seem like a lot of money, but that's 49 bucks he doesn't get to spend on stuff he wants, right? Let's see, Troy paid $49.34 in interest. Okay, so a word problem is just a problem where they tell you a little story. So a table, fill in the table. When it says calculate the following, calculate the following. But when it starts talking about Troy, or when it's giving you something, it's a word problem, and really to be correct, we need a sentence explaining the answer to the word problem. Okay. Now, say question 3 it doesn't really tell you a story, does it? So, it'd be really up to you. If you just want to do the calculation, it's fine. But what I say is whenever they tell you, if you know anything about the people involved or the situation, then it's a word problem. Okay, just to try and make it clear. Okay, so that's how you do these. And really, if you look at those questions and then you look at the key questions, you'll see that they're pretty close. Okay. And so if you look at a key question, you're not really sure how to do it, you can always go back to those support questions. Okay, we already did key question 1. We already looked at that. So key question 2, 3.5%, right? 3.5%. That's our rate. May. Okay, so we need to know how many months are in May, and then how many days are in May, and then I think you'll be doing the calculation based on days, right? Pretty good. Eh? Okay. In 25 days. Okay, so these are the sorts of things you look them over, and it should be pretty straightforward. Nadine, question 4. Nadine has a term deposit. So a term deposit is a longer type of investment. So this is $5,000 at 4.8%. So maybe she sold a truck or something. She receives the interest from the deposit each month. That's, again, a kind of a typical way to structure these. What some people will do then is if they're retired or if they need the money, they'll just use it as a kind of an income. And if not, then they'll just reinvest it. So that's a type of financial vehicle that people use, vehicle method. So write a sequence to show the accumulated interest we'll receive for the first 5 months. So basically you're going to be doing a chart, month interest total, right? Okay. And then you'll work out, the interest for 1 month, and then you can just add it each time. And for interest, that's going to be total interest, right, for each month. So the first month it'll be 1 month's interest, the second month it'll be 2 months' interest, and so on and so on. Draw a graph to show the terms of the sequence. So, we are expecting, if you'll look back in the course material, I think it was time in months, and then this is interest. That's going to be in dollars. And don't forget to put a title on your graph. Okay, it's just an important thing to do. All right, well, I guess we better leave it there right now so we can make room for the next class. So if you have any questions, feel free to contact me.